Okay, on my clock. Hello, Arthur.
Hello,
Uh,
Chris. How are you?
last time we were talking about the nuclear medicine, so today it's on different topic.
Completely different thing.
Yeah, but I guess both of the topic in nuclear medicine and CBCT tomography is also very interesting. It's like very interesting phenomena that people can use the physics phenomena can use to visualize human body. I'm uh, you know I like it very much. I like physics in that way. I don't like the counting the specific things from patterns. I like to see how the phenomena can be used by people to do fantastic things. Like the
Yeah,
phenomenon.
recently, I think yesterday, I was thinking what a journey the digital imaging have made from, for the last 70 years.
Wow.
It's a huge leap because, yeah, from the, really, really poor things, now we can do almost miracles. We can, deduct, subtract, add.
Yeah.
We can make a miracles. We can. It's
It is
amazing.
the standard processing is developed in the high level, but I'm wondering how the artificial intelligence will affect our diagnostic features. I know that there is so many things that are happening right now in that field that we cannot imagine what will be possible.
Yes, and on the other hand, it's also a hazard that we will get something that it's artificial, and it can lead to misdiagnosis. I think that it's on the algorithm, the AI will learn on the mistakes and improve on the timeline. But yeah, there has to be a human at the end to verify.
Yeah, I think it is necessary, and I'm thinking about the AI more like assistant that you have that
Yes.
you can assist to what to write, what to read, how to read, and so on and so on. I'm using the assistant every day, and I think it's game changer in many fields. And I don't think the imaging will be the standalone island without it. It have to be.
Yes.
Okay.
Yeah.
Can we see
All
how many
right.
people are?
So maybe for our guests that don't know yet, Chris, I will say a few words in the beginning. So I would like to very warmly welcome everyone for the today's webinar for the Diagnomatic Academy. Chris is medical physicist. He works on a daily basis in a nuclear medicine facility where he takes care of quality assurance of the nuclear medicine devices. Moreover, he is a professor, so he gives lectures, he teaches students, and this is his main activities. But as a person who plays on many fortepians, on many pianos. He's got also his own hobbies and interests that are not in the mainstream, and this additional, uh, let's say, hobby thing, it's dentistry. Of course, it's about the money, but I really, really uh, mm, like that you're not close to your uh, main area, but you can also widen your knowledge use in different areas, in different modalities. And I think it's really, really useful that this part, the quality assurance in dentistry, is based on your experience. Because, in my opinion, it's very, very challenging thing because maybe the image analysis is not so sophisticated as it is in CT, CBCT, or MRI, but the very first part, the protocol, the positioning of the phantom can be, this is the most challenging part, I guess.
Mm. With the Phantom from Diagnomatic, it became very easy. At the first few units that I was trying to test, to make some tests, I was trying to do my self-made Phantom of some water bottle with water, because the physics inside it is not so complicated. It's supposed to be some samples inside, some things that you can check the household units around some regions. And so you can try to make it about yourself, but with your Phantom, it's become very easy. So I like to know the phenomenon, and I like that it is very easy to do with your Phantom, and with the software that you provide, it is even more easy to do. But still, as we mentioned, there have to be people that are aware what they are doing and where to click to make it better or make it correct. So I would like to show today how the Phantom looks like, how to use it, and maybe how to try to understand the results from the tests.
Okay, Chris, the stage is all yours.
Okay. I hope the presentation is already visible on the screen. I heard that, and I have my laser pointer in here. I hope also it is visible. At the beginning, I don't want to talk more too much about the physics inside, but just to know that the CBCT is from the cone beam computed tomography. It's not the standard tomography, and for me, this is enough to know that with the standard CT, we have some beam that goes in the specific direction, and there is a specific special area that is in the field of view of the detector, and is much more wider than in the CBCT. In the CBCT, that the beam is like a cone, and in the same time you can visualize more area, so you have a larger field of view at the end, and so that's a phenomenon. And so with the one rotation of the X-ray tube, you have image of much more volume than in the standard CT. So, and also the dose is lower. That's why in case of the dental imaging, it's just one rotation of the CT tube, and you have all area that you are interested in. So let's leave it in that way, and the introduction of the physics inside. And what my task was to test if the equipment works well, to test the parameters that are known to be have to be tested in the case of the CT tomographs. And the Prodent CT Mini is, as I said, a very useful tool. And this is the Phantom itself, and there's inside some modules put it in, and also the tripod is very useful thing. But not always using the tripod. Sometimes I'm using just the CT, so just the Phantom fixed to the machine. But if you want to use it with tripod, I can show you that this little screw, not screw hole, I think, is inside at the bottom. It is regular tripod mounting point, the same as for example, cameras. So you can use your tripod, or you can order the tripod from Diagnomatic as well. Okay, this is example how I use the tripod. My tripod, I have the older version. As you can see, the not so fancy one, but still useful. You have to put the Phantom in the field of view of the machine. There's a CT tube, and there's a detector, and it's going around the phantom. In this here, you can see the tape. Sometimes I'm using the tape to mount the phantom into the machine without the tripod. It's very very important because sometimes when in here I don't have a tape, but the placing the phantom is very very comfortable, so I didn't have to use it the tape. Um, it affects what you see, what you can see at the end, or at the image, and sometimes you need some many tries to position the phantom in the right way. Maybe some higher, maybe some lower, maybe to the right, to the left, to the front, to the back. And it's very important to at the end to evaluate the results. As you can see in here, this is my picture. I had to take a photo of the already mounted phantom and make some marks that where it's supposed to be and where level in correlance with the other things to make it work for me in that specific machine. So I suggest to the people who starting the stand, don't give up. The one bad image is not the fault of the phantom. Maybe it's the fault of positioning, maybe the person. And when you finally find the right position, just write it down where it's supposed to be, and every other test might be easier and easier after all. Okay, the difference between, in this case, this is a Carstream 800, 8100 3D. It might be different in different manufacturers, but I would like to show some difference. In this case, you can see the area that it will be visualized by the tomograph is a large area, and it don't have to be like that. In that large field of view, you don't have to worry about the positioning so much. But if you have a field of view like this one, and it is also might be also only available like in here, only available field of view like it. The field of view is small. It's just for several TIFFs. It will be hard to position the phantom at the first time in the direct position. So don't give up. But you have to know that there are differences between. You can see in here. You can choose so many field of views. In this version, you have only the one position that is available. And also there will be to choose the parameters, and usually I'm using this one. This is like a female one. This is a child, female, male, and fat, and maybe strong man as a man. I'm using, because the phantom is like small, so attenuation is also smaller than with the big guy. So I'm using this option on this picture, and there is a. You can see also that is important that the kilovolts is like 90 kilovolts from the sun, and it affects the results in some module, but I will come back to it later. Okay, 90 kilovolts and 5 milliamperes is like, what is inside the phantom? The phantom, this is the version that I have the older one, the gray tripod, the phantom, and some modules. The modules inside is for different purpose. They are the K-imaging quality parameters that we might say it's like if there are artifacts on the image. How to check if there are artifacts, if my machine, if I have good quality stuff to imaging, when there is nothing to image, there's supposed to be nothing on the image if there was nothing inside. If I can see some things that are not in the phantom, that are artifacts, and I might be different. Also, the Housefield values is values that are that you can read from the image. There's the numbers of the numbers hiding behind the pixels. And for CT, for X-ray imaging, the Housefield units is a standard for writing the values of the pixels. So the different materials have the different Housefield values, and we have a specific design of module inside to check the Housefield values for specific samples are correct. Image uniformity. If you have a uniformity parts of the phantom, the image is also supposed to be uniform, so we can check the uniformity as well. Noise level in the imaging is also is often described as a standard deviation of the values in the pixels. And we have a model that we can do the evaluation of noise level also. And of course, contrast and geometric accuracy is also important things. I can show you all the modules. As you can see in here, the different modules. I have also the phantom in here. If you can see my camera, the phantom is like this shape and this size. I can hold it in my hand. It's not so heavy, not so big. It's smaller because the dental stuff is like for heads. So it's looks more like smaller. That's not the chest like in standard CT. And you can see that there is a hole for the tripod at the bottom, and you can unscrew the cover. So this is not sealed one. You can unscrew it, and inside you can. I have some modules. They look like this, and you can change the direction. You can change the ways that they are inside. All the models have the different purpose. I can show. I would like to show it on the presentation what you use for which one. And this is noise model and uniformity model, and this is a standard model that there is nothing inside. It's just PMMA, and if there is nothing inside, it's just PMMA. It's supposed to see the uniform image on the screen after exposition. If you can see some artifacts, there might be something with your machine. So image uniformity and artifacts, and also noise level, it can be checked on this part on this model. So just nothing, just PMMA, but three important things of your image you can check on it. And I think it's good. It's a nice phenomenon. As an example, you can place a region of interest in somewhere in the image. This is an example of the image from the uniform module. And from the region of interest, if you have suitable software, you can see what is the mean value of Housefield units, what is the standard deviation of Housefield units, and so on, so on. So in the standard deviation usually refers to noise level, and the mean value of the Housefield is like a specific value for this kind of material from this kind of imaging. In this, usually for standard deviation, so for the noise level, we are using the larger field of larger region of interest, and for checking the uniformity, we are using the smaller region of interest, but in the different place from the phantom. If that is the same value, mean value of the Housefield units in the site of the phantom as is on the and so as you can see on the border of the image field, there might be some differences in values. Sometimes it's normal, and you have to check if this in the way that the producer, the manufacturer of your equipment says it, that it's normal to have this little darker pixels on the outer field, on the outside of your filter view. Okay. Another model for me, the most interesting model, is the model for checking the house field units for different samples. And this is model when you have inside the contains 15 millimeter diameter rods made of various materials, and the material inside is like Teflon, nylon, water equivalent, polyethylene, and air. So one of this sample is the air bubble inside, but other are some specific density materials. Higher density, there will be different color, you can say, but different value of the Housefield units on the picture. And it in the radiology, it's supposed to be in the Housefield unit scale. It's supposed to be that the water have the zero value, and the air is supposed to have, I think, minus 1,000 or something like that. But you know, in the CBCT, it is not direct like that. And the water equivalent epoxy might be zero when you have 120 kilovolts and you have a standard CT scanner. That it may suspect that the water will be like zero household units. In the CBCT and in different energy of the photons, because the kilovolts transfers to the photon energy. We have a slightly different values, but on this phantom you can check it how it is, and you can then refer to the first test that you've been doing as a reference. So as I said, these modules will be visualized in the different colors, the values levels. And you can see it is in Polish, but this is the air sample, and this is water sample, and this is the highest value is a Teflon sample. So you can see the water is between the air and the Teflon, with highest and lowest. There is a water between those two samples. I'm telling you that because on the next picture, I think I switched the direction of this module, and so we have the darkest and the white and then the brightest sample in here. So in here you can see the water. So if that will be the standard Housefield values for the water, you can suspect them to be the zero Housefield unit. But in here you can see this minus 151 Housefield unit. It is not the problem. It's just you have to know that the CBCT values might be different, and it also depends on the how high energy photons you are using for imaging. And in case of CBT, it is 90, it's not the 120 like in the standard CT machines. So for each sample, you can check the mean value of the Housefield unit, and then you can compare it later in the test. You can compare it if it is on the correct level or not. Is it something changing or not? We had one problem to solve, because customer sends us the report that they are seeing some ununiformity around the phantom, and they suspect that our phantom is not uniform in the correct way that it's supposed to be. But it appears that the position of the samples module, it was unfair. You can see with the cone beam tomography, the beam of the radiation beam goes in like a cone shape. And if you have the shape like this, you can also see some shadows from that samples in the slices above and below. In this case, if you would like to check the values from that slice, it may affect what you are reading. So just try to put the samples, this kind of samples, in the most middle part of the beam, so most parallel, to avoid that shadows effect that appears in here. So we can see in here those shadows effects are affecting also the image of the sample. So it might be one source of a problem. So just I'm just telling you that because if you're doing you have that problem, you might say that phantom is wrong, but no, not phantom is wrong, but positioning of the phantom is wrong in this case. Okay, the next module is to estimate the contrast of your imaging device, and there are some objects resolution like pattern, high contrast pattern inside of specific line pairs per centimeters, and there are also a single little dot. If you know what is modulation transfer function, and if you would like to assess your contrast and that with that technique, it's also available here. I cannot show you on the picture in here, but I know in some slices on some slides there is a dot high dot that for modulation transfer function. But in my case, it's fair enough that the line pairs are enough to assess the contrast. In this image, you can see that all the set of the line pairs are visible, are recognizable as a separate line pair. So the contrast is on the high level. So even the higher line pairs per centimeters are visible in this image. It is not often. It is often available in that way, but is not. This is the way of measuring the contrast. You can just take a look and see it is okay. If your contrast will be getting lower and lower, that something is happening with your CT, and you have to tell it to report it to the service, to your manufacturer, that is something is happening. Okay, low contrast section is for low contrast. There is a similar little lower density model samples inside, but with the same material, and the smaller. I cannot show you because in my version, in Polish version of this Phantom, we don't have it this one, but it is available. You can order it with that low contrast section also, and you can see this is a high contrast resolution model, and this is low contrast because there's a low difference between density of the outside material and the inside material, and how many of the low contrast samples you can see. It is a level of your reference for the future tests. Okay, geometry model. It is like holes in that model that they are in specific position, and you can check on the image if the position that you are looking at is the correct one. It is 3 centimeters, I guess. And there is also a different technique like verticus to aluminum wire ramps, aluminum wire ramps. I'm not using this technique, but the software is using this technique also to assess the slice dimension. And this is how the image look like. If you have the holes, you can check with your software if what is the distance between the center of this holes, and it's supposed to be like 3 centimeters. And also the holes are of specific size, so you can check the size of the holes. And if you have a software, you can see that the rounded ellipsoidal shape is like this is the wire that is normally like round wire, but in here, because it is a slice, looks like more like ellipse. And so measuring the size of that ellipse may allows you to. This is the bigger picture of that wire. The size of this ellipse you can estimate the slice thickness. So you can do it with that. Okay, so that are the modules and how they look like, and I have some images how it might look like on the diagnomatic software. I guess I know Arthur can you tell me that if you can see my screen and also the diagnomatic software interface.
Yes, I can see. It's all right.
Okay, so if you are using the diagnomatic software, your life getting very easy because you just have to
One more thing, Chris, you can change
yeah.
the language version in the software, so it will be
No, I
more.
prefer Polish, but I understand. Okay, and then in the English version, you can add the test. So if you have your image, you can export it to the DICOM, and the DICOM you can add it in here as a test, and the software will automatically evaluate your image and will try to find because not always it is the best thing. Sometimes you have to do it manually to show the software which part of the which model where it is. But in this case, you can see that the software choose the right slice to evaluate the samples. In this case, this is a pixel intensity for different samples, and their samples are correctly recognized, and they have values for the samples, and if there is it is correct, if this intolerance level, and the test will be on the green, so it's test passed, so you can okay, and you can see the pattern along the time curve that it is on the same level. It's not supposed to change anyway. So it's a good thing to have to monitor if your values of your pixels are on the same level as it's supposed to be. If there will be something with your CT that will be visible as a trend for lowering or hiring, or maybe some other ununderstandable way to that they are changing. The pixel intensity is one of the tests. The geometry is another test that you can see that the software recognize the places where the hole are, and also there are some image of these wires. So in this case, that places are the places where are some measurements are being made, and slice thicknesses are different tests. It is evaluating this dot, and the slice thickness is also at the correct level. So so the test is on degree. Homogeneity is the test that in this case is failed somehow. You can see that homogeneity is avoided about for the based on the 4 or 5 region of interests, and as you can see in here, I can see the artifact, the round artifact. Something is happening with the because I know that the space in the phantom is uniform. That the rounded shape patterns are from maybe from the detector, some bad pixels on the detector, or maybe some loses on the CT tube. I don't know. I would have to report it to service that I can see on the image some artifacts, and it is in homogeneity. There it affects some homogeneity of my image. And also in the test, they call it artifacts. It does that
Sorry, Chris.
yeah.
So just wanted to say that when you see red, it's not the issue with the software, but it's good that the software have analyzed the homogeneity and found some mistakes that gives you a red lamp to say okay, something's wrong.
Yeah.
You so this is the core, the essence of the software, that when the tests are all green, it's okay, but when it shows amber or red alert, it shows us that we should focus and pay a little closer look for those slices and analyze it, because there can be some malfunction. The machine is broken and we should report to the service. This
At
is
the
very, very important.
it you can see on the top of the test that needs attention, that something needs attention because something goes wrong. So you can this is the first selection of where to put your patient, your activity to check what was wrong, what might be wrong. It might be wrong with the positioning, it might be wrong with the some different things, but it also might be wrong with your quality of your stuff. So good to know that red, yellow, and green is like lamps for making the noise level. Noise level is okay, but you can see on this on the same model you can avoid the noise level. Okay, I know that I can show you some enough different. In this case, for example, pixel value, just like pixel intensity is wrong. The test is failed, but it's not the software. It is not the machine. This is the positioning of the phantom, or maybe software somehow didn't recognize correctly the module. It happens sometimes, but you can do it manually. You can evaluate it to say it like it is the my module with the samples are on the slices. Like I know that it's on the slice. So let's see, 300. Oh, I know. It's supposed to be in here on that slice. I can, but 344. But in that case, this slice is the last slice and is not the correct slice. So there was problem with positioning the phantom. The slice, the samples with this was too low or too high, so it is outside, nearly outside of the field of view of the imaging. So I cannot do the test correctly because the samples model was in the not correct version. So it's a combination of software that doesn't work because my phantom wasn't positioned in the correct way. So I have to again do the test and correct the position. So then might be evaluating again and find out if there is okay. I don't know. It's the topic will be much more wider, I think. But I had a half of an hour, and I think it's like maybe some comments.
I think that we can treat as a entering point. We can listen the feedback from our audience, and if they will have some suggestions that they would like to pay closer attention for some aspects, for some details of the QA protocol, QA procedures in CBCT, we can redo deeper dive into some more sophisticated, more detailed analysis of some aspects. Now we have just started to show, because yeah, not everyone have to be interested, but just to bring some new things. And for me, it was also kind of new experience, learn new things from your.
As a physicist, at the beginning, you're trying to do it by yourself because you are understanding the phenomenon and you're trying to figure out how to do the phantom. So I did it with some bottles with water and some samples inside. I trying to do it by myself, and it took a year, and there are still some fixing to the phantom and so on, so on. After I bought that one from you, it makes it very easy. For many years I'm using this phantom and it works great, and it's even at this stage it's very durable. I even it is unbroken right now, but I had some issues with holding it. So I think it's a very nice tool for evaluating the tests of the CBCT, and with the software, it's very easy. Make my life easier. So I like it. I like it, and I'm still can say that it's worth the money.
Especially when you make it's your profession to make the QA if you are a service company, and the time is important. So with this set with the Phantom and software, it gives you you can make a full process in 15 minutes or 20 minutes instead of hour and a half or two, that after the acquisition you
No,
need to verify and analyze all the slices, count all the
biggest problem
needed
was
tests.
biggest problems was like in the dental software don't have the option for checking the household units. They need some other some different tools, but not the household units. They are not interested in. So read the household units from the designed dental software I cannot
It's
do that. The distances, the geometry, they may do it, but the standard deviation and the mean values are not able. So
not accessible.
yeah, they are not physicists, so they are not interested in
Yeah.
how the values there.
Very, very interesting. Uh, okay, I think that we can now go to questions. If anyone got question, please write in the chat. Paulina, do we have anything to answer?
Oh, yeah, there is a chat. Yeah.
I think that you made so clear presentation that there are no questions.
So sorry, it was problem. So.
But the issue with the noise in the contrast in the HU model that was connected with the level with the position of the model uh, referring to the con beam. It was very interesting that the Hansfield unit, the sensitometry model, should be in the middle
Yeah,
of the beam, because otherwise the echo
may affect what you are reading on the modules. Yeah, no, it is something that you don't know before it happens. If it
yes,
happens, you can try it and you can complain from the customer that what's going on with your model. There's a problem, but you know that your samples are clear, are uniform in the density. There's no problem with what's supposed to be, and so to figure out what is the reason of that phenomenon, it was very interesting. I thank you, the Tomasz, my friend, physicist, to figure out what it might be came from. So in that field of knowledge, you have to be open to new solutions and new problems and some unusual explanation about what you are seeing and what's the problem.
we've got a question. Please explain CTDI measurement procedure. Do you measure the dose CTDI measurement
No,
in
in
conbeam
that case,
CTs, or
no.
is it the regular CT?
Maybe in Poland it is like the special test we're not doing in the. So I'm not doing it. So I'm not ready to explain it. I'm sorry.
Does this phantom can be used in Linux CBCT? I think no.
I think the
Or
Linux
maybe I'm wrong.
CBCT is a very useful tool, but in the field of dentistry, it is like a small one, a specific one. So I think the Tomasz our friend Tomasz might give the webinar about the CBCT overall, and
In the
yeah,
radiotherapy. The Linux, I think, got the dedicated
yeah,
Phantoms test tools. I think it will be more. It should be our MK2 Phantom, bigger one, or
yeah.
regarding the electron
The smaller one,
densities. Yes,
like your head, maybe
sure.
so this is dedicated only for the
And
small
then in the Linux, I think we should have a body shape Phantom, bigger
one.
one to have. Yeah, but
And
still, I think we can focus on the Linux in the next meetings, but with Tomasz. Good proposal. Okay, so I see that we ran out of questions.
Okay. I will
Thank you
say
so
hello
much, Chris.
and thank you. How hi and thank you. That's my response. As always, I was very glad to tell you something about my work, and I hope we'll be seeing each other in future and other webinars.
Thank you. Thank you for everyone for joining. And we warmly invite you for the next one. Soon we will share more details about when and what we will concern and talk about. Thank you, Chris. Thank you all. Wish you a great day. Bye bye.